All right, so we're on 8-3, special right triangles today. I'm pretty sure this is new for you. This special right triangles doesn't go away. Um, this is the first time I think you've seen it, I think. In geometry, we use it fairly often. In Algebra 2, you typically get to it at the end of the year to help you prepare for pre-calc. And then pre-calc on, you use this all the time. So you might as well kind of start now, okay? I understand that looking at two right triangles, you're probably thinking, why do I need to memorize something new? I can use Pythagorean theorem. If you look at number 1, for example, they didn't give you enough information to do Pythagorean theorem. You're going to have to know this sometimes anyway. Okay? So 45, 45, 90, and 30, 60, 90 triangles follow this special pattern. So kind of like when I said a Pythagorean triple the other day was a 3, 4, 5, or a 6, 8, 10, right? These have the same pattern every single time. So if you look at the 45, 45, 90 triangle, if these angles are the same, then the sides across from them have to be the same, right? So let's say for just a moment that this is a 1, then this has to be a 1, and then we're going to do Pythagorean theorem for just 2 seconds. 1 squared plus 1 squared would be 2. Square rooted would be the hypotenuse, okay? So this shortcut is helpful because let's say I said this is 5. Instead of doing the Pythagorean theorem, I know that the hypotenuse is 5 square root of 2. I didn't do any math at all, okay? 30, 60, 90 is a little bit different. Across from the 30, we call it x. Across from the 60 is x root 3. The hypotenuse is 2x. For example, if I said that this was 10, this side would be 10 square root of 3. This side would be 20. And you don't even have to do any math at all. Does that make sense? And obviously you can't, because if all I gave you was this 10, you don't have enough information to do it any other way anyway. Am I making sense? So you're going to have to memorize those eventually. Not today, but eventually you'll have to memorize what goes across from which one. Okay? This whole chapter, we're going to be simplifying square roots. So if I say 10 root 3, you don't want to give me whatever that is as a decimal. You want to leave it 10 root 3. Okay? All right, number 1. Is this a 45, 45, 90 or a 30, 60, 90? 45, 45, 90. So what I'm going to do is, this x is kind of confusing. I'm going to kind of scribble it out for just a moment, right? You have a pencil. You can erase it later, okay? I'm going to scribble out the x, and I'm going to set up my 45, 45, 90 triangle. What I'm saying is I'm going to call both of the legs x's, and I'm going to call the hypotenuse x root 2, just like the special triangle above it did. Do you guys get how I'm kind of setting it up just like that one? Okay? So they are asking me for this side. They want the hypotenuse. Well, if this is x, if x is 5, what's the hypotenuse of my triangle? 5 root 2. What did they call it, though? I scribbled it out. What did they call that? They called it x. So x in this problem is 5 square root of 2. Do you guys get what I'm saying? The reason I scribble out the original x that they had is because that confuses me with the red x root 2. So at first I scribble out what they had, I find it, and then I'm like, oh yeah, they called that z or whatever. Okay, you don't have to do that. It just, I think the first day or two until you're super comfortable with the triangles is a little helpful. Okay, let's. All right, what kind of triangle is this one? 45, 45, 90. So again, for me, I'm going to scribble that out. If you want, you could just be like question mark. Hey, I'm looking for the hypotenuse of this triangle. But having an x there confuses me because for me, these are x, x, and x root 2. So their x here confuses me with my x there. Do you guys get what I'm saying? So again, I scribble it out, and I go ahead and fill in the sides, and then I find what they were looking for. Okay? So x with my special right triangle is 11 square root of 2. If I'm looking for the hypotenuse, it's x square root of 2. What did we already say x was? 11 square root of 2 with the other square root of 2 still there. Does that make sense? I basically substituted x in as 11 square root of 2 because that's what it is. The square root of 2 times the square root of 2 is the square root of 4, which is really 2. So it's 11 times 2, 22. What did they call this? So x in the problem is 22. The x that they were looking for is 22. The hypotenuse is 22. Is that okay? If I lose you, say something. On this one, is it a 45, 45, 90 or a 30, 60, 90? 30, 60, 90. So I'm going to scribble these out again because that's confusing for me. I always do it in the same order. I always do across from the 30, then across from the 60, then the hypotenuse. That kind of helps me memorize it. You don't have to do it that way. Any order is fine, but eventually you'll have to memorize what goes where. So if you look at your special triangle, what's across from the 30 degrees? What do they call that on your special one at the top of your paper? X. So across from the 30 is X. So here, across from the 30 is X. Across from the 60, what do they call it in the special triangle? X squared of 3. So this is across from the 60. The hypotenuse, what do they call that? 2x. So I've set up my special triangle. This is a different triangle. We had 45, 45, 90s. This one's a 30, 60, 90. Does that make sense? Okay. So I just put everything where it goes. So I'm going to have to start with the only thing they gave me. The only thing they gave me was the 7, right? So I know that x is the same as 7. So I know that this side, this leg, is 7 square root of 3. And I know the hypotenuse is going to be 14. Everybody get that? So I'm going to go back to what I scribbled out. What was this? A y? So y is 7 square root of 3. And what was this then? X. So x is 14. Is that okay? If it's 2x and they called x 7, then 2 times 7. That is the only way to do it, is the special right triangle stuff. Once you found that second side, I suppose you could do Pythagorean theorem if you really wanted to, but at that point, you might as well just finish the problem without doing any math, okay? What kind is this? 45, 45, 90 or 30, 60, 90? 45, 45, 90. So this one, I don't have to scribble out the x because that's what I was going to call it anyway, right? Across from the 45s are x's. The hypotenuse is x root 2. You can cross them off if you want to, but I was going to call it an x anyway. Does that make sense? Okay. So the only thing they gave me was the 15. 15 is the same as x root 2. In math, is an equal sign, right? 15 is the same as x root 2. I need to solve for x. So what do? What's in the way of x being alone? The root 2, what's it doing to the x? Multiplying. So what do? Divide. You guys see that? What you do to one side, you do to the other, right? So x is equal to 15 over the square root of 2 for just a second. Why can I not leave it that way? You can't have a square root in the bottom. You can't have a root in the denominator. So to get rid of it, you have to rationalize the denominator. If you're in Algebra 2 right now, that should be pretty simple for you. If you had Algebra 1 last year, it might be a little bit harder to remember what to do. So obviously watch me, and if it's not good enough, ask, okay? So you can't have that in the denominator. To get rid of a square root, you just multiply by itself. That's a property. It makes it go away. You'll see that in a moment. And what you do to the top, you have to do to the bottom. Because really, I'm just multiplying by a 1. I'm not actually changing the problem, okay? The numerator is going to give me 15 root 2. The denominator, square root of 2 times square root of 2 is square root of 4, which is really 2, okay? So x, which is their x, it's the same, is 15 root 2 over 2. That's all they wanted, right? Is that okay? Any questions yet? Okay. The length of the hypotenuse of a 45, 45, 90 triangle with a leg, find the length. Did I say the word find? Find the length of the hypotenuse of a 45, 45, 90 triangle with a leg of 8 centimeters. I'm going to draw a picture. 45, 45, 90. Find the length of the hypotenuse. I'm going to call it question mark. I don't want to call it x because that's confusing to me. Okay, so I'm just going to be like, hey, find the hypotenuse. A leg, so pick one. I chose that one. It's 8 centimeters. Okay, so let's use this new information. Across from the 45s are x's. What's the hypotenuse? Like on our special triangle. Yeah, x root 2. So if this is x, then what's the hypotenuse? 8 square root of 2. That's it. You didn't even have to do any math. That makes sense? Okay. When you get to the back side, what I'm going to do at the top, you have a little margin there. I'm going to draw the 45, 45, 90 and the 30, 60, 90 again, so you don't have to keep flipping back and forth and maybe getting confused. So I'm going to do that at the top. You don't have to if you don't want to. I just think it's nice not to flip over and over again. So at the top of your paper, if I were you, I would put this, your 45, 45, 90, your x, x, x root 2, and your 30, 60, 90. Now, obviously, it doesn't matter where you put the 30 and the 60. You just have to be careful when you fill in the sides, okay? So across from, across from the 30 is your x. Across from your 60 is x root 3, and your hypotenuse is 2x. Okay? So on this one, this confuses me. I'm going to scribble out the x and the y. I'm going to go ahead and set up my x, x root 3, and 2x. So you have to be very careful. Across from the 30 is x. Across from the 60 is x root 3. Hypotenuse is 2x. No matter how you rotate that triangle, that's always still true. Okay? So I have to start with the only thing they gave me. They gave me the 8 root 3. So I have to solve for x. If this is 8 root 3, but we call this x root 3, what's x? 8. So this side is 8. So what would the hypotenuse be? 16. So I have to go back to what I scribbled out and see what they called it. What did they call this? This one was x. So x is 8. And what did they call this one? Y. So y is 16. Are you guys okay? On the next one, I want you to set up your special triangle. So your x, x root 3, and 2x. You try to do that. So number 20, you fill in the side. So again, I'm going to cross off the x and the y. That's confusing to me. Across from the 30, I'm calling it x. Across from the 60 is x root 3. The hypotenuse is 2x. Everybody okay with that? All right? 2x is the same as 15. In algebra, that's what that means. So if I solve for x, I'm just going to leave it as 15 over 2. I understand 7.5 is the same, but when we put it in here, a decimal with a square root is just kind of weird, so we typically don't do that, okay? So this is what they called y. I'm going to go ahead and say y is 15 over 2 and circle it. You guys get what I'm saying? Okay. I'll circle that so I don't lose it. So over here, I'm going to say 15 over 2 root 3. There's nothing else I can do to that. So what did they call this side? This one was x, right? So x is 15 root 2, or excuse me, 15 root 3 over 2, or 15 over 2 root 3. It's all the same. Sure. Let me show you if you, we'll have one where we can do more. For example, if this was a reducible fraction, 16 over 2, you would have called it 8. If it had been, I think in the next question, we're going to have what you're asking me. And if that's not it, let me know. But we'll have where we can do more math than what we did here. Okay? Is everybody okay? All right. Go ahead and fill in your sides for me, please. So again, I'm going to cross this off. You fill in your x, x root 3 and your 2x. So across from the 30 is x, which they already had, but that's okay. Across from the 60 is x root 3. Hypotenuse is 2x. Okay? I have to start here. That's the only thing I can start with. So 14 is the same as x root 3. How do I get x alone? Divide by the square root of 3 on both sides. So x is the same as 14 over the square root of 3. Why is that not done? Square root on the bottom, can't have that. So multiply by square root of 3 over square root of 3, and you get 14 square root of 3 over 3. Okay? That is what they called x, right? X was x. Okay? So I'm going to go ahead and circle that so I don't lose it. And I'll write that in here so I don't get confused. Okay? So now I'm missing this side. This side, the hypotenuse, is 2 times x. So 2 times 14 square root of 3 over 3. I went ahead and made 2 over a 1, so it's a fraction times a fraction, if that's helpful to you. Whenever you multiply fractions together, you multiply the numerators together at the top and the denominators together at the bottom. So what's 2 times 14? 28 square root of 3 over 3. This doesn't reduce. 28 over 3 doesn't reduce, so there's nothing else you can do to that one. This is what they called y. If this had been, again, 28 over, I don't know, 2, I would have reduced that. If this had been a perfect square, like a 4, I would have said it was a 2. If this had been a non-perfect square, like 12, I would have made that a 4 and a 3, would have pulled out the 2. Do you see what I'm saying? So if you can do anything else, great. If not, then just leave it the way it is. Okay? Find the length of the side of an equilateral triangle that has an altitude length of 24 feet. I'm going to draw a picture. What makes a triangle equilateral? All the sides are the same. If all the sides are the same, what does that mean? All the angles are the same. It's also equiangular. If all the angles of a triangle are the same, what are all of them? Yeah, 180 divided by 3 would make 60. That one word equilateral told me all that stuff. Okay? The next part is altitude of 24 feet. Altitude starts at a vertex, goes to the opposite side, making a right angle. So this is a right angle. You can't really see what it is. Okay? 24 feet. The question was, find the length of the side. So pick a side. Doesn't matter. I'm going to pick side. I'm not going to call it X because that's confusing to me. I'm just going to put a question mark. Okay? When I did that, I have a 60, 90, 30. I have a 30, 60, 90 triangle. You guys see that? So if you're comfortable looking at this inside the picture, for me, looking at a picture inside a picture is difficult. So I'm just going to look at this left side. You don't have to do what I'm doing right now. It's not necessary. It's just easier for me. So now this looks like one of the simpler problems from before. Okay? So go ahead and set up your x, x root 3, and 2x. So across from the 30 is x, across from the 60 is x root 3, and the hypotenuse is 2x. Is that okay? So I have to start with the only thing they gave me. 24 is the same as x root 3. How do I solve for x? Divide by square root of 3. What you do to one side, you do to the other. We can't leave it this way. So I have to multiply by square root of 3 over square root of 3. So I get 24 square root of 3 over 3. What's 24 over 3? 8. So 8 square root of 3. So this side here, well, no, just kidding. The x is 8 square root of 3. Sorry. I already found it. So if I'm looking for this side, how do I find it? 2x. So I'm going to take 2 times 8 square root of 3. Well, what's 2 times 8 square root of 3? 16 square root of 3. So the length of each side of that triangle is 16 square root of 3. Is that okay? You need me to go back to the part? All right, last one. What shape is that? Square, because all the sides are the same. Therefore, all the angles are the same slash right angle, right? If this side is the same as this side, then this angle must be the same as this angle. This is 90, and these are the same, 45, right? So x is 45, right? I have a 45, 45, 90 triangle. So again, that's confusing me. I'm going to call the legs x's and the hypotenuse x squared of 2, right? So if 8 is the same as x squared of 2, how do I solve for x? Divide by the square root of 2, and then I have to multiply by root 2 over root 2. So that's 8 root 2 over 2, which is 4 root 2. They didn't call it x, though. They called it a y. So y is 4 root 2. A leg, or side of the square, is 4 root 2. What questions do you have, if any? Are you sure? Okay.